Hi, this is Mr. Cappert. In this video, I'm going to show you how to analyze your testing data that you took for your Trebuchet catapult. Now, I had you do 15 different trials where you recorded the mass of pennies that you put into your counterweight and then how far it threw. So the first thing is you want to put in the mass of the pennies. You guys have that on your form already. Just put it into this Excel doc. You'll have to open this on a PC. It won't open on an iPad. And then right here in inches, put how far it threw. So you've already done that. I also had you find how far the counterweight falls before thrown. And I have a message here too for you if you forget what I'm saying here. So you enter that. That's all the same, right? Maybe it fell 10 centimeters or 3 centimeters. Make sure you put that in centimeters. That's important. And then the mass of your empty counterweight. Because when you're firing, the mass is everything hanging from that counterweight. So that would be your bucket and the axles and the shaft collars that connect it to the throwing arm and the pennies that you have in there. Both of those are weighing down your arm and helping to throw the marble. So fill those in. Typically, I have students create this chart. You guys did do up to about, can't remember how far ahead you guys go this year, probably up to here. Since we don't have a whole lot of time this year, I have created this graph for you. So that was the whole reason for making this chart, is to get to this equation, this graph and this equation. So what this shows is perfect world. This plots out ideal. In a perfect world, this is how far it should throw, range, how far it should throw with a given mass in the counterweight. So if you put 1.4 kilograms, it should have thrown about 70 meters. But that wasn't the case because of friction and air resistance and other things, material deformation. So this is what you got right here. This is the real world. So I graphed our actual here versus your total counterweight here. This is automatically calculated. I made this for you. So you will get this equation. This is the all-important equation for determining how much mass you should have for a given range. So on competition day, I will say, okay, the target is 2 meters away. Use your equation to determine what the mass should be. Now the problem here is that Y is your total mass. Your total mass of your counterweight equals 0.1039 times the range. That would be the 2 meters that I just gave you, plus 0.7993. The problem here, Y is your total mass, not just the pennies. Total mass is the pennies plus the weight of your assembly, of that bucket. So in order to figure out how many pennies, you need to use this equation and then subtract your empty counterweight mass. Does that make sense? So Y is your total amount of mass, total amount of mass. So your total amount of mass is the bucket and the things that connect it and the pennies. So if you want to know just the pennies, you have to subtract off your empty counterweight mass. So that will be the equation that you use. In this case, I would subtract 0.1 kilograms from this, and that would tell me the mass of the pennies. So once again, I will say, for instance, you're throwing 5 meters. You will say, okay, the total mass of my counterweight is 0.1039 times 5 meters plus 0.7993. That's the total mass. Well, I want to know the pennies, so I'm going to subtract 0.1 from that. So ask me if you have any questions. That is a little complex. Thank you.